till now we have already studied about the satellites and planetary motion, and have studied about what is the time period, what is the velocity of a satellite. In the last class I was telling you that a satellite is moving in an elliptical orbit. Based upon this elliptical orbit, Newton and Kepler actually already gave that the planets are revolving in elliptical orbits. Kepler gave us some gravitational laws which are actually controlling this motion of all the planets, and we'll be studying today Kepler's law. Kepler's law, let me begin the class with understanding the planetary motion and what Kepler said about planetary motion, Kepler's law. Now, Kepler said that he gave us three laws which actually control the motion of the planets around the sun. Now, the first law is, it is a law of orbit, that every planet is revolving in an elliptical orbit with sun at the focus. You see here in the last class I was telling you, if this is the sun and if sun is present at the focus of one of the elliptical orbits, the planets will be revolving all around here. This is the orbit of the planet, this is an elliptical orbit. This is what we have studied in the previous class. So Kepler said that every planet is moving in an elliptical orbit, and these orbits are bounded orbits. Every planet revolves in an elliptical orbit. So you can take down this statement that I'm saying. Every planet moves around the sun in an elliptical orbit, and these orbits are bounded orbits. So elliptical orbit, 1 point, and these orbits are bounded orbits. This is the first one, second one. When I say bounded orbits, what do I mean by these bounded orbits? This means that these orbits are stable orbits. The net energy of the planets moving in this orbit will be negative. It will be lower than zero. In that case, when a body is having negative potential energy, that means negative total energy, that means the body is stable and it will be continuously revolving in this elliptical orbit. If the energy was positive, then the planet would be in such a state that it could leave the orbit and could fly off. But we generally don't find this situation. The planets remain in this elliptical orbits and they move here. Now, sun is at the focus. Sun is at the focus, and I'm drawing two focus here. One focus here also I'm drawing. So two focus we have. These are the foci of an ellipse. Now you see here, planet is revolving. One time it will be at the nearest point with respect to sun. This is the planet which is revolving, and one time it will be further away from the sun, planet at the second position. You see your sun is here, this point will be nearest to sun and this point will be further away from the sun. What is this position called? In the case of satellite, we have given you apogee and perigee as the farthest and nearest position respectively. Here in this case we have the nearest point is known as perihelion. The nearest point is known as perihelion and the farthest point is known as aphelion. Aphelion is the name of the farthest point. Now how can you remember this? It's very easy, as I told you in the last class. Do remember FANP, fan and P. This is the shortcut to remember. F farthest, aphelion, N nearest, that is perihelion. Do remember this. Farthest, aphelion, nearest, perihelion. That is what I have given you. Nearest, perihelion, and farthest is aphelion. That is what I have written here. That is easily you can understand with the shortcut way to remember, fan P. Next thing, first law, they are moving in an elliptical orbit. Then already I have told you, because the velocity is not as equated by L root gm by a, it is not the speed. And now one more thing, if the speed you take at 2 points, let me mark here speed as v1 and here the speed as v2, the planet speed, when it is nearer, it will be revolving with a higher speed compared to the speed when it will be further away from the sun. When it is further away from the sun, then its speed will be lower. So I am writing here v1 will be greater than v2. And we have seen this relation when we conserve the angular momentum. In that case, we realize that the speed is more than it is nearer to the sun, and when it goes further away from the sun, the speed will be lesser. That is what I have written. V1 will be greater than V2. Next part, the second law of Kepler. The second law states that it's the law of area. Second law, law of area. Very simple law it is, law of area. Now this law says that the line joining to the planet and the sun sweeps equal area in equal interval of time. I am writing here the law, the line joining sun and the planet, the line joining sun and planet sweeps equal area in equal interval of time. Sun and planet sweeps equal area in equal interval of time. Hope that's easily you can get that in equal interval of time. This is what is the second law says, that sweeps equal area in equal interval of time. And it's quite easy to understand with this statement what I mean to say with the second law. Suppose if I draw here again the position of the planet keeping the sun at one of the focus. This is the sun, and see, I'm going to draw the elliptical orbit in this way. This is the elliptical orbit. This is what we can observe. Now you see, when planet is revolving, let's say planet is here. At some time it is at this position. If I join this line with sun, if I join the line connecting the sun and the planet in this way, after some small time delta t, this planet will reach at this particular location, let's say making an angle d theta, let's say. In time dt, it moved from here to here and sweeping an area given by the shaded portion. This is what has been given in time dt. It has moved from this position to this position, sweeping an area. Now in the same time dt, if I take planet's another location, suppose the planet was here. Let's say the planet is here, and the same time dt it reached here. So if I connect these two positions, see what I'm going to obtain. I'm going to obtain the same time dt, this time it has covered this much distance, and the area that it has swept, that will be given as this. This will be the area that I am showing you with the shaded region. This will be the area. In the same time dt, the first case, planet has moved from this position to this position. The second case, it has moved from this position to this position. Kepler's second law says that in same time interval, the line joining sun and the planet sweeps equal area in equal interval of time. That is, rate of sweeping of area is constant. Now that means if I mark this area as delta A, this area will be also given as delta A. This you should be very well aware of. Both the areas will be equal, or let me write the law, dA by dt is constant. The same thing can be proved also. We can treat this as a triangle. We can show that the same thing can be proved also, but that proof is not required in our syllabus, that is not in our curriculum. So let's not get into the detail of the proof of this law of area, and let's directly switch to the third law. And before that, let me tell you about this law of area once again. Remember, you have to check this line. In some time dt has moved here, this line has moved here. The area that it has swept, this will be the area. This has to remain constant. If you take a large time interval, let's say the time of, let's say 1 month. In 1 month, the planet has moved from here to here. And the area will be swept will be this much area that you can see. And in the second motion, let's say planet has moved from here to here in the next 1 month. The area swept will be the same. And the same thing can be shown also, it can be proved also mathematically, but that is not required, so we're not going into detail of that. You should know that this only, that the line joining will be sweeping equal area and equal interval of time. Let's go ahead after learning the second law. The third law is quite simple. And third law is based upon that planet is moving in an elliptical orbit. First of all, I was talking about this elliptical orbit. This is the first law. I told you that every planet is moving in an elliptical orbit. Now I have shown you two axes. In the last class I told you this is the minor axis, this is the major axis. Let me give you the length of this major axis as 2a, and let me give you the length of this minor axis as 2b. If E is the eccentricity of this elliptical orbit, what I'm going to mark here, let's say E is the eccentricity. If you are unaware about the term eccentricity, you will learn in the conic section chapter in maths. When you refer to conic section, when you study about ellipse, you'll understand about its eccentricity. Sun is lying at the one of the focus, its coordinate will be minus AE, 0. I can give you the coordinates, and that the same thing also we will study in conic section, minus AE, 0, and here the another focus will be AE, 0. This is where the focus will lie for an ellipse. Now let's refer to, I gave you all the names. Now see, this much length A, this is length A, this is length A. This is known as semi-major axis. This is length B, this is length B, this is known as semi-minor axis. Third law, the third law is law of periods, and again it's very simple. Third law of period, I'm writing here only. In this we have, the law is very simple. We have the third law, the square of the time period of revolution around the sun is proportional to cube of the semi-major axis of the elliptical orbit. So third law says that square of time period I'm talking about the entire time taken to revolve all around the sun, square of time period of planet's revolution is directly proportional to square. I'm rubbing this part. This already I believe that you must have written down. E is the eccentricity of the ellipse is directly proportional to cube of semi-major axis. When I say semi-major axis, that means I'm referring to length A, semi-major axis. Hope that you are clear about the third law. It says the square of time period. Now see, square of time period is what? T square is proportional to semi-major axis, that it will be proportional to A cube. This is what as per the law states, that because semi-major axis here will be, we have taken total length of the axis as 2A, semi-major axis will be A, and this is semi-minor axis, that is B. So we are considering this as the term that I am referring here. T square is proportional to A cube. Now how to get it? We have derived all the equations treating the orbit as circular orbit, and we can idealize the situation. In case of circular orbit, what will be the case? The only change between a circle and an ellipse is this, that the radius of the circle will be equal to both the same major and same minor axis. That is, in this case, A will be equal to B, and that will be equal to radius of the circular orbit. The only difference between a circular orbit and an elliptical orbit. So if I try to prove it, we already know. We know for circular orbit, we have already derived this, we have already proved it. For circular orbit, T was given as, time period was 2 pi by under root gm and A to the power 3 by 2. This is what we have shown already, where A is the orbit of the circular path.
Hello students, welcome back once again. Now as you know, we are right now discussing various chapters and question based upon those chapters for AIIMS exam, keeping in mind specifically your All India Institute of Medical Sciences entrance exam for the admission in MBBS courses. So today we are in a very good chapter, very simple chapter. Sometimes student used to say like this, sir, this chapter is very less important or no important, not important, like that. But my point is, let us say a topic X is mentioned in your course and you are preparing for AIIMS or IIT JEE Advanced or like that prestigious exams, then you should not left any smallest topic untouched. And this one is a very simple topic, that is universal gravitational aspects, you can say associated with these type of things, fine. Or you can say circular motion, or you can say your rigid body motion. So, all these are very important topics. What I am trying to do, I am trying even to give attention to on small concepts, fine, like very simple concept if it is mentioned in your course curricula, then I always used to represent and explain it in a very proper fashion, fine. Let us take a look this question. Two solid spheres of same material, same radius r touch each other, then the force between them varies as. Now, very simple but slightly confusing. Fine. Fine. R. Clear? Now, we have to find what exactly the force between them variation is taking place, means the force depends upon which power, r square, r cube, 1 upon r square, r to the power 4 and so on. These are two solid spheres of the same dimension, same material, same size, everything is same. Okay. So, first thing is how we can calculate it. What should be the idea? So, first thing that comes in mind, okay, let us assume that entire mass of both these solid spheres is situated at their respective geometrical centers. Is it like that? Is it true? Let us try it. What I mentioned? So, from this relation, no problem. Now, from here what I can say, F is equal to minus G, minus because gravitational force is always attractive in nature, minus G m fine upon r square. So, m means 4 by 3 pi r cube rho into 4 by 3 pi r cube rho upon r square. Now, I hope you will definitely agree with this term. Okay. So, from here I can say that F is directly proportional to r to the power 4. Why? Because this much, this, they all are constants, fine. So, if they are constant, so at the top I will get r to the power 6 and at the bottom it is r square. So, simply by solving you can say that force is varying with 4th power of the radius of individual, you can say these solid spheres. So, do you think this question is difficult? Not at all, very fundamental, only arrangement of the terms, that is it, fine, as per the requirement of the problem. Otherwise, simply you can write down minus gm square upon r square. Got that idea? And one thing that you should remember every time, when you find any problem, then do not consider it as a very difficult one. The way I explained this question, read, think, draw the diagram, proceed, fine, because it is next to impossible that, I mean, you are solving 10,000, 20,000, 30,000 questions. So, is it like that you will get same question from there? No, obviously not. Fine. So, rather than increasing the number of questions solved, you should try to increase the level of understanding. Fine. Next is the gravitational field, that is it's mentioned. The gravitational field intensity in region is given by vector E is equal to 2y I cap plus 2x j cap. Fine. Newton per meter. Now, find the work done by the gravitational force to shift a point mass 5 kg from 0 0 0 means from origin to 2 2 2. The distance measured are in meters. Now, so moment we will read this line, find the work done. So, the first you can say expression or formula that will come in our mind is obviously we are supposed to do something like this. Fine. Now, obviously I will do the same process, but before that let us come on for a very important point. Actually in your this chapter, because I am sure if you are preparing for your AIIMS entrance exam after passing out 12th class. So, obviously you have the fair idea of all the topics of physics from class 11th and 12th both. Now, the concept of gravitational force, gravitational field intensity, gravitational potential energy is similar to electrostatic force, electrostatic you can say potential, electrostatic field, then you can say electrostatic energy. So, all these. So, you just prepare one chapter, one topic, and from the correlation your next is again prepared. The formula even are same. E is equal to 1 upon 4 pi epsilon naught q upon r square is the electric field intensity, and E gravitational is equal to minus g m upon r square. So, charge is equal to mass and 1 upon 4 pi epsilon naught is equal to capital G, that is universal gravitational constant. Fine. Now, let us try to find the solution. So, in this particular formula, if we can do something with this f and dx, then hopefully life is going to be more beautiful. Okay. Let us take a look. E is equal to I cap j cap Newton per meter. Fine. Now, from here what I can say that I can find the potential. You know why? Because the formula is V is equal to ED. ED. Okay. Means E is equal to dV by dx, dV by dr. Yes, somehow like this. So, let us differentiate over here. So, I will write it del x I cap. I even can do like dx also over here, that is not a problem. Fine, dx is same thing, delta x is same thing, it is going to be the same thing. Now, from this relation first we have to find the values. So, let us apply it over here. So, it will give me 2y, then when you apply over here it will give you 0, and then this property that will give you 2x. Fine, dy is something that is applicable over here. Fine. So, dw is equal to 2 2 2 and this 5. Fine. So, 5 into 2, 5 into 2, just take a look over here, 5 into 2 y dx. Fine, I cap j cap is meaningless. So, y dx plus s dy. Actually this 2 out. So, w is equal to m mass. So, that mass is equal to 5 kg I placed, that is to y dx plus x dy. X dy. So, 5 into 2 y dx plus x dy. After putting the values, after putting the values, after putting the values, W is equal to 10, 0, 0, 2, 2 d by dx xy. Fine. So now I don't think it's going to be difficult. First, second, second, first, that is y into 1 plus this x into dy by dx. Fine. So from here you can easily find out the value as, I think I should erase out this portion. Fine. So it is going to give me what? X into y, only x into y, and that to limit is 0 to 2, 0 to 2. So W is equal to 10 and x y. Fine. So put the values over here, what you will get? 2 into 2, that is 4, 4 into 10, that is 40 joule. Fine. So 40 joule, D is your correct option. The question was simple, but yes, up to some extent you can say some sort of visualization was required. Fine.